If partial pressure of nitrogen in the gaseous mixture containing equal mass of carbon monoxide and nitrogen is 0.5 atmosphere. This is the partial pressure of nitrogen in the gaseous mixture. Then the total pressure of the gaseous mixture is, we need to just find out the total partial pressure. Total pressure of the gaseous mixture. The formula for this case we can use here, that the partial pressure of nitrogen should be equal to mole fraction of the nitrogen into P total. In this case you need P total, so this can also be written as PT is equals to P nitrogen divided by X N2. This would be the formula that we are just going to use here, this one. Now in this case, what we need first, we need Xn2, that is mole fraction of nitrogen. It would be equal to the moles of nitrogen divided by the total number of moles present in the mixture. In this case, if I talk about nitrogen, let us assume that we are considering X gram or W gram you can take. I'm just taking here the W gram of nitrogen divided by its molar mass. Moles of nitrogen we have. Now similarly, should be divided by moles of nitrogen plus moles of carbon dioxide. In this case, moles of carbon monoxide, from where we can get, we know that W is the equal weight of carbon monoxide as well as nitrogen. That's why I've taken W here and just divided by the molar mass of carbon monoxide, that is 28. This would be the value, and if you solve this for the value of Xn2, that would be 0.5. If you solve, you will obtain that. And now what would be P total? P total is Pn2. Pn2 is clearly given here. Just have a look on that. This is partial pressure of nitrogen in the gaseous mixture containing equal mass of CO, and N2 is 0.5. So this is 0.5 divided by Xn2, that is also 0.5. So the total pressure becomes 1 atmosphere. And if it is so, option 4 becomes your correct answer. Just choose it as your correct answer. After that, question number 72. Under low pressure, minimum deviation from ideal gas behavior is expected from. We know that real gases do not show ideal gas behavior, but all those gases which are permanent gases are showing the minimum deviation from ideal gas behavior. And among the given gases, only nitrogen is there, that's a permanent gas, and that's why it is showing minimum deviation from ideal gas behavior. That's why correct answer becomes option 3. Let's take next question. Question number 73. Molality of an aqueous solution of 0.9 mole fraction of solvent. It means in this question you have the mole fraction of the solvent. I'm just taking here X solvent, that is 0.9. So what would be the value of X for the solute? It would be 0.1, because we know that total mole fraction is 1. That's why we have X for the solute, that is 0.1. Now what is molality? That is moles of solute divided by mass of solvent, and it should be in kg. Now what would be the number of moles of solute? The number of moles of the solute are, we know, 0.1. We have assumed. Further, divided by the mass of the solvent. What would be the mass of solvent? Mole of solvent, we are assuming 0.9 from its mole fraction. Multiply it by its molar mass. What is that? 18. Water it is. That's why 18 is the molar mass, 18 gram per mole. Now, we need just mass in kgs. That's why this is in gram, and I'm just dividing it by 1000. So this 1000 will come here. This would be your value. Now, just solve this for the value of molarity. It would becomes 6.17 m. This would be your final answer. And if it is so, option 1 becomes your correct answer. That should be chosen by you. How many maximum number of electrons can be identified with the following quantum numbers? In this case, if you look at, you will see 3 quantum numbers are given. The n value is 4, L value is 2. That n value is 4, L value is 2. These are representing here 4 d orbital. And in case of 4d orbital, we know that 5d orbitals are present, and in this case, there would be 5 electrons which have plus half spin. While if I talk about the next set of electron which is anti-parallel to these electrons, they have the spin quantum number that is minus half. So with the spin quantum number plus half, n value 4, L value 2, 5 electrons are present there. So in this case, you'll choose option 1 as your correct answer. And after this, it's a turn for next question. Question number 75. If the uncertainty in velocity of an electron is 1 into 10 raised to the power 7 meter per second, then the uncertainty in position of electron will be. On the basis of uncertainty in velocity of electron, you need to just find out the uncertainty in position. We know that delta V into delta X is greater than or equal to H by 4 pi m. This is the formula that we use. Now in this case, we have uncertainty in velocity. Let's place the value here. That is 1 into 10 raised to the power 7 meter per second into delta X. That's equal to 6.626 into 10 raised to the power minus 34. Just divide it by 4. And what about the value of pi? That is 22 by 7 or 3.14 I can write. Further, what is the mass of electron? We know that mass of an electron is 9.1 into 10 raised to the power minus 31 kg. In this case, the mass of electron is also given here. Mass of an electron is given, that is 9 into 10 raised to the power minus 28 gram. And what it become in kgs? In kgs, it would becomes 9 into 10 raised to the power minus 31. In kgs, this value would you get. And on solving, you will get the value of delta X. Let's write it. 6.626 into 10 raised to the power minus 34 divided by 10 raised to the power 7. This value comes here. Now 4 into 3.14 into 9 into 10 raised to the power minus 31. Just solve this for the value of delta X. If you solve this, this value is 5.86 into 10 raised to the power minus 12 meter. This you will obtain. And if it is so, option 2 becomes your correct answer. Just choose that. After that, question number 76 let's take.